see, I started a while ago, so there's really loud typing in the background. Okay, so anyway, if I have this curve, okay, and I want to estimate what happens at like 3.03, I can write the equation of the tangent line at 3, and then I can fill 3.03 into the tangent line, which is probably lots easier than actually filling it into the curve. Especially if I don't even have an equation. There's many professionals out there working today. I'm just talking. I was going to do this anyway before I did number 2. I was going to reiterate before we move on because this is linearization. After that, we'll have Euler's method and then some other things that also we use to approximate. So you got to really understand each process. Linearization works because of the local linearity of functions that are continuous and differentiable. Therefore, differentiable will take care of all of that. I was going to talk about linearization a bit more before we move on, so you can really get it. You know if it's an under approximation or over approximation by the concavity of the graph. There's another thing, but we can get to that later if you want to. This is only if it's differentiable, but you wouldn't be doing it if it was not differentiable because you couldn't find the derivative and you couldn't linearize it. But if you look at something that's not differentiable, you cannot count on local linearity to help you estimate something that's a little bit away from the point. By the way, do you see why the tangent line is undefined there? Because there's a whole lot of lines that touch that point. Okay? So anyway, we don't want to use it to estimate something really far away, unless on the off chance that we know that it is increasing so incredibly slowly that we could go pretty far down, but that's a whole nother concept. You want to stay close, okay? So, number 2. Let's see. All right, so number 2, so without a calculator, you're approximating y is equal to 4 plus sine x at x equals 0.12. So, and they went ahead and told you, cut and paste AP things, but hopefully you would know to linearize it at 0 because it's the closest thing you know about sine. But they went ahead and told you to write the equation of the tangent line at 0. They didn't even use the words linear approximation. But you do see the word approximate at the beginning, okay? So if I fill in 0, I get y is equal to 2. Are y'all okay with that?
Yeah.
So I have the point 0, 2. I have to use the chain rule to find the slope.
That's what we did wrong.
We're so stupid.
Who's we?
We were like, square root of 5.
Sine 0 is.
Sine 0 is.
Oh,
yeah, I
did
that for so long.
I forgot that.
We said sine 0 was 1, so we had y equals square root of 5. So I was like, how am I supposed to know the square root of 5?
And then I just
Derivative of sine is cosine.
So I was like, I realized
I just did it with the negative 1 half.
Also it was plus, and I found this.
Did most of y'all know that sine of 0 is 0?
Yeah.
Okay, good.
I did.
I just did the
I
chain
forgot
rule.
to figure it out.
Even think of the graph for one thing.
I
We
do
know.
circle in
I
my
didn't
head.
know the circle in my
You were
head.
dumb.
So anyway, back to this. It's also great. I mean, I became such a better learner, unfortunately as a teacher, not as a student. But when I always teach my students, think of the picture. When I think of sine of 0, I'm not thinking of the unit circle or my 1, 2, 3 chart. I'm totally thinking of the picture of sine and tangent both go through the origin. Cosine starts up high at the amplitude. So, I mean, I think thinking of the picture of sine comes right through 0, 0, doesn't it? Pi over 2 is on pi at 1, if that helps. I think so much about pictures. Hopefully, I teach you like I started today with lots of pictures. Like, it just helped me. I had to draw it out to understand it as a teacher and explain it to my students. Back to this. So anyway, 0, 2. My big deal is just 2 or 3 people are still messing up on the chain rule. So you hold the inside still, and you bring your 1/2 down times blah to the negative 1/2, and then go back into the inside. And so if I want f prime of 0, if it was free response and I'm showing my work, the sine of 0 is 0, and the cosine of 0 is 1. So I get 1 over 2 times actually 1 over 2, because this goes down to the bottom, 1 over square root of 4. And so the slope of the tangent line is 1/4. So now I'm going to write the equation of the tangent line. Y minus y equals m times x minus x. And then I'm going to fill 0.12 in for x into the tangent line instead of into the original. So I have y is equal to 2 plus 1/4 times 0.12 minus 0. So I have y equals 2 plus 0.12 divided by 4 is 0.03. And so my estimate is 2.03. It'd be, I'm guessing we're really, really close to if we filled in.
Yeah, I looked it up. It's 0.2029.
Okay, girls, that was extremely straightforward. No, super serious, like where we are right now in the end of November. That should be second nature to you. We've written the equation of the tangent line, I think, since mid-September. So,
You're not wrong.
So what are the issues?
I began.
Today was just like an
I
forgot to put the negative 1/2.
I literally got everything right, like even the slope, and for some reason I decided to divide 0.12 by 2 instead of 4, so I did 0.06. And I don't know why.
So the issue is you're ready for Thanksgiving.
Yeah.
It's not your calculus.
No, I don't know.
It's a basic arithmetic skill.
It's just
It's my brain.
First grade math
With as
skills.
many voices on number 2, I'm just a little worried about my teaching. Are y'all okay?
No,
You are so correct when you say that is straightforward.
It's so
just none of us did it right.
We're just
Somebody did it right?
Alana did.
Okay.
I was so close.
For one,
Like,
B,
I
once I
understand,
left,
and I was like,
I'm
I'm
very
very
nice.
nice.
Because I didn't know about picking cavities, so for one B, I just found like what would the slope be if we had done that
I had
with
some
like
really
this.
different issues.
You take the second.
I just like.
What was the lesson reading?
So
no way
that means it's concave down, which means your line would have to have been over of 6 inches.
Okay, so I put the actual values left.
Because I thought that.
Yeah, but I need to know, you know, has to be a
The
line.
reason that I did it was I said I took the all the way down the approximation from the page 2. I took like the slope there, and I thought since the slope was less there, then it's decreasing at a faster
From
rate.
now on, we
And I
need to
just
take the
did it
second.
Did you get partial difference?
Girls, remember,
Yeah.
that I talked about over approximations and under approximations, which is also gonna happen with our Riemann sums. Okay? So make sure you're listening, okay? Let's look at Riemann sums for a minute. If something is steadily decreasing, and you go from the right, which would be the blue y values, okay? If I have 3 rectangles and I go from the right, if it's always decreasing, it would be an under approximation, right?
Yeah.
Okay. If I have something that's doing a little bit of both, and I have these y values out there, and I'm doing a Riemann sum from the right, so it's on my syllabus to talk about today anyway, these are under, but what are these two? Over, okay? So you're probably not going to ask you if it's an over or under approximation on one that's not steadily increasing or decreasing, okay? And I'll show you something that'll help you on the next test, and maybe on a worksheet that I'm giving you that I'll learn from one of my students, so I'll just be transparent about that. But I got to go on and talk about this anyway. And I tried to avoid it in your 3 homework problems because it says it in the book, and I didn't know if you know what all was happening. You could be asked to find rectangles from the left, or a left-hand Riemann sum, from the right, from the middle, and all of these would still have the same width, okay? So this is my width, which I would just call dx for right now. It would be like you're going from A to B and dividing it up into 4 rectangles. And that would be the width, okay? Like if you're going from 2 to 16, that's let's say if I go from 2 to 14, that's 12 units divided into 3 equal parts. You know the width of each rectangle is 4. There's a lot of concept to talk about, so please listen. For some reason your computer's open, so listen carefully, okay? If you're going from the left, you still have this green width. And the left, you would use the purple sticks, the purple Y values. And you would add up these. Does that make sense based on what I talked about the other day in the homework that I only give you 3 so you could think about it and struggle with it. So we have purple rectangles and red rectangles, okay? Given this little thing I'm doing right now, they'd probably be sort of similar answers. Because both of them, some are under, some are over, okay? Anyway, sorry. The mid, I want to talk about a bit because we're going to be doing them a lot. A mid rectangle is really better of the 3. And you could justifiably wonder right now why we just don't run around and do mid all the time. Why am I talking so much about left and right if we know mid is better? When you do mid, you'll still have 4 rectangles. They're still going to have a width of 3, or whatever the width is. The green width will still be the same, saying that this is 3 units apiece, okay? Doing mid does not affect the width. But what if this is 1 and this is 4, you go right in the middle of 1 and 4 and fill it in to find that stick or that Y value. I mean, obviously stick is not a real calculus word, but do you see they still have the same width, but your height is found by saying F of whatever's in the middle. All right? Y'all with me there?
Yeah.
And so they're still the same width. And the yellow would be the best that you know of right now. We'll talk about some more today. Now, I needed to go in and address this, and I always hate saying this word. Fortunately, I don't think they say the word in the AP exam. But there's 2 words that as a math teacher that I thought somebody that hated math inserted or hated their math teacher. They must like math because they apparently written some curriculum hundreds of years ago that made me say these words today. But maybe they hated their math teacher and thought it'd be really funny to make them say words like latus rectum. So I don't know if y'all know this. On an ellipse, most of y'all learned the eccentricity. It helps you know you didn't do it very much, but it helps you know the width of that ellipse. Okay, it's called eccentricity. This line through that is technically a Latin term called the latus rectum that I just call the LR if I like teach it pretty deeply, okay? But anyway, another word is that if the rectangles are underneath, and keep in mind I always taught co-ed till I came to New York and, had to talk about the period of the sine wave and, girls with blush and guys with sneaker and it's the length of the cycle. And so you can't get away from that. You gotta go ahead. You gotta go ahead and laugh at us high school kids and address it, okay? So then, and also so many graphs, I was just erasing as I drew them. Whether it was a circle with a center or a parabola that looked like something else. Anyway, I was just constantly like, so this graph, let's erase it. So it's not on the board too long for us to look at. Anyway, the other one is if it is inside the circle, like these are also called inscribed rectangles. Every single one of those is inscribed. And if I had a graph like this, the ones from the left, the ones from the right would all be outside the circle. Outside the graph. Do y'all see that?
Yeah.
By the way, before I tell you the word that I'm avoiding saying, if you went from the left, you see that one would indeed be 0. That's okay. One of them, the height of the rectangle, could be 0, and you just don't get anything there, okay? So the purple ones are inscribed, the blue ones up here are circumscribed, which is really hard not to say something else, okay? Fortunately, they instead of circumscribed, our book says upper and lower, okay? upper and lower, but boys are just like they wince when I say circumscribed. They're like, oh no. Anyway.
I bet a CT. I bet the say
And you know, as a teacher, when you're trying not to say the word, then invariably you're gonna say the word. So back to this. Yeah, not gonna say it once. It's just like with seek and etch, you know, you have to write it so often every now and then you're just gonna write the word sex on the board. But back to this, as you're trying not to. We get to say lower and upper, okay? So if they said, the reason that I have to go over this with you is if they're not gonna say, I have seen them once say inscribed. That just means they're all inside, okay? So if I'm doing inscribed, which also the terminology would be lower, and I have something like this, if they're if they're inscribed, if they're lower, and I'm told to do it, they wouldn't say left or right. They would say, do 4 inscribed rectangles. That means this one I need to be careful and go from the left and the left. And this one, do you see these two? I would need to go from the right.
Yeah.
So sometimes you have to do what they say, so it's not always left or right or mid. Sometimes they may say lower or upper. And you have to stop and think, well, each individual of the 4 rectangles or however many you're doing, you might have to stop and change your mind. Left or right. Are y'all okay with that?
Yeah.
Okay. All right, now, so I wanted to talk about that, and we'll call them lower and upper, left, right, mid. I'm going to address this too. Even better than mid is trapezoids. So in their hunt to find the area under these weird shapes, which there are no formulas for, but we need them. Think of all the weird, interesting shapes that you see in architecture or shoes or calculators or, you know, all sorts of things that we like that are sleek looking, that aren't real geometric. If you look back at old cars, they're very geometric. And they're sleeker now, but somebody must know the area volumes of those weird shapes, but we don't, okay? So it's an interesting shape, like even that pencil sharpener. We couldn't find the volume of that pencil sharpener without calculus, okay? Did y'all see what I mean? All right, so these are like mathematicians of old just crunching in the hunt for how can we figure out how to find the area and volume of irregular shaped objects that aren't just straight geometric, okay? And so in their pursuit of doing this, somebody said, well, hey, mid's great, but girls, if you blow it up and it's something really big, like an airplane that you're gonna build, like I can think of shapes of airplanes, they're not geometric. So we better hope somebody knows the volume of those, right? I'm sorry, I'm thinking of all these things that you need to know the volume of. And I'm going to say one. The interpreter, I think I told your class about, is now a math teacher? Yeah. Angie. Her husband, I love their story. His name's Aaron. He's a trucker, a heavily tattooed trucker. And Angie is an interpreter turned math teacher. But she was so excited, because you know, she got so excited about math. She came to me one day with Eric's notebook that he kept in his truck. And when we go to fill up the tank, it's cylindrical, which we all know the volume of, but you can't see inside of it, right? Because you've seen these tanker trucks going down the highway and they're like silver or something, or pigment.
Yeah.
And as you fill it up though, she's like, oh, I'm so excited because he was telling me that the volume wasn't something that we like if this is the volume of gas, Elaine, or milk, or whatever the tanker truck is carrying, you can't see when it's filling up, but as it fills up, you don't know the volume of something weirdly shaped like that? Think about that for a minute. It's got a really weird shape because the cylinder's turned on its side. You're not filling it up like we do a glass of water. It's turned on its side on wheels. So do you see it? It's filling up. You can't see it, plus you don't know the volume of it without calculus. So somebody had done the calculus, and he's got this ledger and notebook in his truck that will tell him when to stop, when to click the gas pump. I don't know if you've ever filled up a gas tank. But you see that, especially if it's flammable, there, I don't know the rules, but it was on those sheets of paper. You can't fill it up too full because you don't want it to be completely full. You also don't want to start spilling out if you've overfilled the tank. So it's like a related rate problem mixed with volume and area that we're about to find. So do you see how important in the future world it was that these mathematicians were looking for these things that we have now, like even this pencil case. If I actually found the volume in this pencil case, you couldn't. Do you see all these curvy pieces? This is not a cube. This is not rectangular. Y'all see this sleek design, so what do we do? Okay. Alright, so anyway, in their pursuit of it in the 16 and 1700s, when we have really records of people like Newton and Leibniz and Riemann and Gauss, well, really Gauss wasn't born yet, but in the 16 and 1700s, we have people that are actively looking for more formulas. They never found them. They never found more formulas. We still, the only ones we have are geometric, like a perfect sphere, 4/3 pi r cubed. But of course they didn't find formulas because you could want a shape like this, it's elliptical. And then you have one that's not really quite elliptical, but you really like the design. I don't even have a name for that, or the pencil sharpener. Do y'all see what I mean? Okay, so there'd have to be an infinite number of formulas. Do y'all agree with that? Yeah. So there has to be a better way. All right, so somebody decided to divide them up into 4 trapezoids. And please remember what I'm saying right now, okay? Because don't forget the theory. You've got to find a derivative and you just think, oh my gosh, it's earth changing. You really know what a derivative is. I mean, I guess given a calculator, if you're trying to find f prime of 1, you could find 2 points close to that and find the difference quotient. You know what it means. Do y'all see what I mean? So, if you, sorry I got so much I want to say at one time about this. If you were asked to find the area under the curve and you forget where we're headed with this, or you have an equation that's very difficult for you, or your brain just like gets one of those brain freezes before Thanksgiving, don't forget, if I was going to estimate it, I'd use 4 trapezoids. Do you see how great that catches the area? Yeah. And you could probably pick out your answer choice from that. Are y'all with me there? Okay. Don't forget where this came from once I teach you what came from this. Okay? Alright, so we'll do some trapezoids today too in just a minute. Trapezoids are great. So you would think, well, maybe they could just stop there. But if you're talking about an airplane or a space shuttle or a huge building that they're building that has all of these interesting designs that we see popping up in New York City now, if this is really big, I'm kind of worried that I have not really calculated the correct area of that, because that's going to be a lot of space I miss. Are y'all okay with that? All right, so we want to be correct. So let's look at your homework problems, and let's look at number,
It's my chicken and chicken tenders.
Alright, let's look at number 27. Alright, so 27 is, so have your homework out. Y equals 2x plus 5. And we're going from 0 to 2. And we're doing 4 rectangles. We're finding 2 approximations of the area under the graph using left and right endpoints. So we're doing left and right Riemann sums, which is funny because Riemann came a few hundred years after people had actively been doing this. It's just that he did so much more work on it. And he even maybe sometimes didn't make them all the same size, trying to capture different areas. There's another mathematician named Simpson who even did this. Instead of the rectangles, and capturing a lot of area with trapezoids, he came in and found a way to put like quadratics in here. It didn't quite match it, but it was a really cool idea. He found some unbelievable way that it turned into a really catchy formula that I'll I'll tell you later. Before I go on, we're just doing left and right. Riemann sums right now. We haven't even done trapezoids yet. But before I go on, if and when I get to the trapezoid rule today, if I don't, I'll get there right when we come back for Thanksgiving, or some video, one of the two. There is out there a trapezoid rule. Once again, I found myself in Cal 1 taking notes, memorizing it. If you memorize that trapezoid rule, if you're like going off class, which I don't blame you, as fast as I move, but beware if you're studying with somebody from another school, or even possibly talking to an AV student here, or watching a Khan Academy video, or looking it up on Purple Math or Cool Math or whatever, they're going to give you the trapezoid rule. If you memorize that, you'll miss quite a few problems on my test and on the AP exam. They don't want you to memorize the trapezoid rule, so they'll set it up to where you won't get it right if you use it. They want you to understand what you're doing. Your safety net is, there's nothing wrong with adding up 4 trapezoids. I don't need a fancy formula to put on top of all the other stuff I have to memorize in the world anyway. Do y'all see what I mean? You're not even have to add up but 3 or 4 of them. I can't remember the most I've ever seen, but about 4. Sometimes just 2. So you can add up trapezoids, but I want to super warn you. I will show you the trapezoid rule so you will be well versed in it, or I'm sorry, so you've seen it. But if you're studying with somebody from AP Calculus, tell them not to use it. Do not use it. Okay? And I'll talk about why later on. So anyway, 4 rectangles. So y equals 2x plus 5. And we're going from 0 to 2, which takes me to 7 and then to 9. So we have this. By the way, if somebody asks me to find the area under that and they don't tell me that I have to do a certain thing, I would just find the area of that trapezoid. We'll compare that in just a minute and see how good our estimate is, okay? So now I'm going to do 4 rectangles from 0 to 2. So if I say 2 minus 0 divided by 4, do y'all see the difference in 0 to 2 divided into 4 equal parts? Each one has a width of 1/2. So hopefully if I looked at your homework, you'd have 4 rectangles that you're going to add together. And I usually write them like this because if I start writing them out, I don't leave myself room. So I just usually write however many I have right there. They all have a width of 1/2. Be careful. Many times when they give you data in the table, they're not all the same width. Okay? So I'll show you some. But be careful. Right now, when we're in charge of it and it's not data, we just make ours all the same width. That won't always happen. So just be careful. Okay? Now, I'm going to come from the left. And so I'm going to use all of the blues, and I'll never need that last green one if I'm coming from the left. Is everybody okay with that? Okay, because I did this so quickly the other day. They're going to be lower. It's going to be a lower sum from the left, just because this is steadily increasing is the only reason. Now to find this value, I'm going to take f of, you don't have to write this down when you're doing your work, but I need to write it down to flesh out what's going to happen today. I'll start off with f of 0, and then I've got to find f of 1/2, or 0.5 is fine. This is a parentheses. And then I've got to find f of 1, and then I've got to find, it's really hard to draw parentheses next to an f. Oh. Then I'm going to find f of 1.5. Everybody all right with that? You didn't have to write that. I just need to keep going with what I got to teach today and next Monday. All right, you could have just done this. 5, f of 0 is 5 times 1/2. That's 5, not 0.5. And then f of 1/2 was 6, I think, right? Look at your homework. F of 1 was 7. And I don't mind you dealing with fractions. F of 3/2 would have been 8. And so I could do 5/2 plus 6/2 plus 7/2 plus 8/2. But what else could I do to make my life a bit easier? Okay, I could factor out the 1/2 and say 5 plus 6 plus 7 plus 8. Is that okay? All right, so that's pretty smart. I don't have all those fractions to worry about. And so, is it 24? No, 27?
26.
24, 27, 26. 15 and 11 is 26. And so did you get 13?
Yeah.
All right, that's from the left. Now let's go from the right. So I'll erase this and we'll leave our 13 there. I'm just going to erase this part. If I'm going from the right. I'm sorry, what?
Like, can you just keep all of them and
Yes.
set it as 0?
Yeah, you can do it however you want to if you're asked to do some. On a free response, you probably want to just show your work again. From the right, I'm using the red. And it's going to be an over approximation or an upper sum. All right, so I need f of when starting here. The first one I need, if I'm looking at these two, if I'm going from the right, I want to pick this one and make my rectangle. When I get to the second one, if I'm looking at these two, I want to pick the one from the right and make my rectangle. So I have f of 1/2, f of 1, f of 3/2, and all I really needed was f of 4, okay? So I have this.
F of 2.
Thank you.
Right? Yeah.
4/2, thank you. That would be 2. That would have really, I would have wondered why my answer was so incredibly wrong. So f of 4/2 are 2. All right, so I'm going to add this one on. And f of 2 is 9 and 1/2 times 1/2. And so this is just replaced with a 9. I don't want to move too fast, which I guess made this 28. And did you get 14?
It's 50.
It's 30.
I was just doing, because I lose the 5. All I did was add 2 to it. I'm sorry. I should have added 4 to it. Because I got rid of 5 and
Oh,
had.
yeah, you did.
Yeah.
Anyway, y'all tell me it's 30?
Yeah.
Okay. So I get half of 30 from the right, and that's 15. Rights are not always bigger, lefts are not always smaller. It depends on the shape of the curve. Okay? Question?
So when you present your answer, would you say the area is between these two numbers?
We're just getting started. Right now, all you had to do was find them both.
Okay.
Okay? We think it's somewhere around 14, don't we? It is not always the average of the two. This one's linear, so it probably is. But if you start throwing curves into it, you see it could be closer to. So please don't think it's the average of the two. I think if I did mid, which I'm not going to do right now, I think if I did mid, I probably would get 15 in this problem because it's linear. All right, let's actually find the area of this green because it's a trapezoid. I want to go over the trapezoid formula. Oh, that's not green. The formula for a trapezoid anyway, which you had to know for like ACTs and stuff. All right, so also I want to talk about where it came from. We're used to our trapezoids kind of being shaped like that on their base. Right now ours are all going to be upended, okay? Our trapezoids that we draw, you'll see in just a little while, they'll look more like this, okay? So you can kind of think of them as falling down. I'm going to tilt them back up vertically. Are y'all okay with that?
Yeah.
Okay, so it's really just two triangles. So do y'all see a 1/2 base times height plus 1/2 base times height? Hopefully your geometry teacher showed you that. All right, and these two triangles have the same height. Do y'all see that? So I factor out what's in common. I factor out,
It's just one beat, it's a 1/2. But average of the base is 1/2.
all right, girls, so you shouldn't forget the formula if you know where it comes from. Somebody factored out the 1/2 and the height. They could have put, girls, 1/2 h in the front. I have a theory for why they didn't do that I'll talk about. But y'all see I could factor out 1/2 in the common height, but they have different bases, therefore it's a trapezoid. So then I could just add my bases together if I factor out the 1/2 in the common height. How's that? Good. I think that they put the h in the back instead of the front because you already know your formula for a right triangle is 1/2 base times height. And a trapezoid is just a triangle with the top cut off. Do y'all see what I mean? So how many bases does a trapezoid have? It doesn't just have one base, it has two. So you should always and forever, it is not yet another formula for you to memorize if you felt like it was. You may be great at it. We're gonna be using that a lot. 1/2 base 1 plus base 2 times the height. All right, so let's find this. Now these are my bases. The parallel sides are your bases. So in black, these are my bases. So do y'all see this base and this base? Okay, so this base, I've drawn in a lot, but I think it was 5, and I think this base was 9. Was it? Yeah. Okay. So I have 1/2 base 1 plus base 2 times the height, and the height is going to be this distance because it's tilted on its side. So the height of this was 2 units. And I did get 14, which I suspected in this problem because it's linear. That would not have happened had it been curved. Okay? Lesson learned. If you're trying to find the area under something geometric, don't do calculus. Unless somebody says add up 4 rectangles, which you can roll your eyes and go, well, that's going to be stupid because I'm not going to get the right answer, but I could get the right answer if you just leave me alone. Okay? Like if I had a semicircle, my rectangles are going to give me an approximation, but I just 1/2 pi r squared and get it. So watch out. They will give you things that are geometric. Many times they not make you do it a certain way. Don't use calculus if you can use geometry. If you have a curve like this that y'all will see sometimes, and you want to find the area underneath that, please just use 1/2 base of pi. Okay? If you don't need calculus, you don't have to use it unless somebody says divide it up into something. All right, now let's go to number. I don't know if I need to do them all. I probably want to do at least one more. Was one or the other of the last two harder? Or? All right, let's do 31. All right, 31 is y equals cosine x, which is interesting. I just love this. Cosine and sine have so much irrational stuff in them. But what's so weird to me is that when you look at the area under the curves, you quite often get integers, which kind of blows my mind. But anyway. So we're going from 0 to pi over 2 and 4 rectangles. So cosine looks like this from 0 to pi over 2. And so I'm going to go a distance of pi over 4 minus 0 and divide it, I think, into 4 rectangles. So I'm going to divide it into 4 rectangles. And so I'm going to count by pi over 16, which I guess you need the calculator for because I'm not
Pi over 2. Yeah.
Goodness. Sorry. I'm going from 0 to pi over 2, subtract the distance between those two, and cut it into 4 rectangles. So did you count by pi over 8, which you would need a calculator for? All right, so half of that is, wait, I'm doing 4 rectangles? Oh, this is pi over 2. That's why I was going to get it wrong. All right, this is pi over 2. And so this is pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. If I go from the right, so a right-hand Riemann sum, I would use this value, this value, this value, and this value. It would be an under approximation because this is steadily decreasing. So each of them is a width of pi over 8. Do y'all see now we can just factor out that width? And I need to find f of pi over 8 plus f of 2 pi over 8 plus f of 3 pi over 8. And when you're doing a right-hand Riemann sum, shouldn't you always end at your far side? If you're doing a left-hand Riemann sum, you should always start. This one will be included on the left, that one will be included on the right. Neither one of them will be included in the middle, okay? All right, so I've got the calculator pulled up, but it was also an odd, so I guess you could have checked your answers. I mean, I don't know how much somebody asked me to do it, said it was hard, but do I need to say more about this? Anybody have that value they want to shout out to us? Or Caroline, do you have a question?
Well, no, I was just going to say Slater did like weird, like not this right.
Oh, yeah, that's true.
Say,
Slater did something weird. It was like summation and integral.
oh, they
So,
probably used the sigma.
Yeah.
Okay, which is, they're just saying, that's their
Yeah.
way to tell you to add it up.
For the answer to the book.
And I don't know what it is. but for the left, in purple, from the left, I would go pi over a, and I would find f of 0, f of pi over a, f of pi over 4, and f of 3 pi over a. By the way, this one, back on the right, was 0. That's okay. If something starts and the first rectangle has a height of 0, you lose a lot of area in your estimation, but that's okay. All right, now I'm going to show you some interesting sites that I think you can actually get to from my page. But anyway, cosine x. I'm going to go from 0 to pi over 2. Let's have, sorry. It should have given me pi. I want 4 rectangles from the left. Where? Oh, I've got to use this. And it's not doing it. So let me go to this one. Okay, we'll use, I don't know why that wasn't working today. X. Ah, darn. Don't know what's happening. Let me refresh. I've never had neither one of these. Oh, there, I got it. All right, but that should only, oh. That's not going to pi over 2, though.
I think it just doesn't recognize.
Maybe it doesn't.
Wait, are we doing cos?
Oh, yeah, because it reset.
Maybe you could just like put the approximation 6.28.
Let me look for another one. Okay, girls, look up here. C equals 0 is the left-hand sum. However, that looks like a, oh yeah, that's a left-hand sum. And the other calculators I liked a little better because they actually give you the sum. Oh, did y'all get 1.183? Look at your homework or the answer. 1.183. All right, now, and by the way, Caroline, this is what you saw. That's adding up length times width. The notation is trying to tell you. Yeah, don't worry about that right now. Okay, that's not for us right now. All right, C equals 1. Did y'all get 0.7907?
Yes.
Okay, so, but look at the picture. That's what we should have gotten. All right, and then midpoint, watch midpoint, which you didn't do, but those would be the middles. Did y'all see the width of this and I went in the middle? Oh, they did, I didn't, okay? So it should be really close to, in fact, girls, it's actually 1. It's so weird to me that it actually becomes an integer. One was a little more, one was a little less. Mid gives us really good. I don't know if trapezoid's an option here, but I could pull up a trapezoid one that would be even closer. I just happen to know that area is 1. If you go halfway through a sine graph from 0 to pi, It's just so bizarre to me that what's underneath that graph, there's so many irrational numbers that are important in that, you get an area of 2. It's
So
bizarre.
what if like sign gets like
I'll get an area
then
to
it's
change.
like-
I don't even know if it's still an integer, but we can easily look at it later. We're not prepared to do it now, but we can do it next week.
Okay.
Caroline, go.
For these questions, when it was saying like, find it from the left and the right, you find those two values separately, is your answer just like,
They won't ask you to average them or anything. They don't want you to.
so they just want the
That's the-
separate
Yeah.
values? Okay.
And they may say, is it over approximation or under approximation?
Got
They
it.
would only ask that when you could come back with it's strictly increasing or it's always decreasing,
Okay.
okay? And over or under approximation with the tangent line is based on the second derivative concavity, which Grace and I talked about earlier that I said the other day, came up on your quiz though. Are y'all okay with that? If it's concave down, the tangent line's an over approximation. Okay, if it's concave up, then the tangent line's an under approximation. All right, now, let's go to, for 5 minutes, do y'all have this sheet? Let me find it. I don't know what I did with my own. Do y'all have this sheet? I think I passed it out the other day, like Caroline needs
Yeah.
one.
Who's that it?
All right, get the, it looks like this.
Oh, yeah.
I hit it because mine says circumscribed on the top of it to remind me to go
Thank
over,
you.
lower, upper. All right, so get this sheet out. And 4 minutes left. Let's do this. All right, so somebody's already done number 1. And I'm gonna skip it because we've done right-hand rectangles. I'm gonna go to number 2. All right, oh, by the way, Anna, did you do number 1?
Kind of.
Okay, then, well, let's do it. We'll do it real, well, no.
Do it.
Well, what answer did you get for number 1?
For the left one, I think I got 6.75.
Okay, but it says use right.
Oh.
Go.
Oh, wait, no. Then
Wait, hang on just a second.
10.75.
I don't know, we'll find out. Grace? 19 over 20, so you got close to 1. Okay. So Grace did number 1, and that sounds a little more,
This was Eric. I got 0.945.
that's probably 19 over 20.
I think
Emily, will you check for me, please? 19 over 20?
it's 0.95. Yeah.
Okay, well, I was just asking because there's a calculator next to your elbow, but did you work it also, or?
I just didn't know. It's just 19 over 20 is. Yeah,
Did you get the same thing?
Yeah.
Okay, girls, fractions are better to work at. Don't like round anything off. If you have something like 3 over 8, on these, keep 3 over 8. Don't start using decimals. Well, that decimal would end, but that was a bad example, like 2 over 7, okay? Or 2/3. All right, so another thing I wanted to look at when we were talking about who got what answer, if this is 1 and this is 3, and 1 over x comes like this, y equals 1 over x. It's undefined at 0. At 1, I'm actually at 1. And y'all remember this graph looks like this?
Yeah.
All right, well, how many units is this right here is 2. So if I thought of this like as a trapezoid or a triangle, you could kind of estimate the area roughly like that to even know if your answer made sense. Do y'all see the area of a triangle is 1/2 base times height? So my base is 2, and my height is 1 of the yellow rectangle, and I'm getting 1. And so that 19 over 20 looks like it's less than that to me. Do y'all see that? And I didn't draw it very well. It's closer to the axis. So anyway, I do think it's around 1. So that makes sense, what some of you got, which is so impressive that you went ahead and did some of it. Trapezoid rule goes like this on number 2. You're going to need all of your, I don't know why I call them sticks, okay? You're going to divide it up into 4 equal parts. I'm going 2 units from 1 to 3. And so I went 2 units divided into 4 equal parts. So they're each half a unit wide. So this is 1 1/2, 2, 2.5, 3. We know what we're doing from the left and the right, what will you in the mid, what will you do with trap that you'll have to do for homework, okay? You're going to need both sticks for your bases, and then you have this trapezoid. I drew it on there for you how well it fits. You have both of these sticks. You need both of them. Do y'all see that? You're going to need every single thing. So I have 4 trapezoids. Each one has a width of 1/2. Right now, that will not always be the case. Okay? So do y'all see I need f of 1, which is 1. Oh, by the way, the formula is 1/2 base 1 plus base 2 times the height. If I made you do right, left, mid, and trap, you're probably really close to each other. Trap's a little better than mid. All right, so f of 1 is 1. F of 3/2 is 2/3. And then I'm going to reuse this. Oh, how did I get 2/3? 1 over 3/2. Wouldn't that give me 2/3? Then the next one is 2/3 plus f of 2, which is 1/2. Then y'all see I need the 1/2 again because it's a piece of both of these.
Yes.
All right, and then 1 over 5/2 is 2/5. I'm going to need it again. Remember that when I show you something next Monday. And then f of 3 is 1/3. I'm going to leave it there, but you see you can easily add up 4 trapezoids. And hopefully it'll be closer to whatever the answer is, which I haven't told you yet. And you don't have to do this sheet right here. I will post some AP problems for you to do. I tried to make copies, but tomorrow, the religious studies is taking up all of the copy machines for Thanksgiving. So every time I went, there were different leaves and turkeys and things like that. So I'll just attach it to you, okay?
Thank you.
All right, bye girls, happy Thanksgiving. Have a great Thanksgiving.
In class, when you were trying to decide whether to do this or I didn't remember if you had.
Grace, now what?